Welcome to Print Reading for Concrete. I'm Dan Dorfmiller, and I will be your instructor for this course.
The program has been divided into 7 videos. Unit 1, Overview of Prints, Lines, and Symbols. Unit 2, Construction Math and Application. Unit 3, Reading Scales. Unit 4, Specifications. Unit 5, Reading Architectural Drawings. Unit 6, Reading Structural Drawings. And Unit 7, a final test.
There is a student handbook and study prints. The downloadable materials are the student handbook, and each one has a test your knowledge activity, and there's one for each unit. There's Gateway Tower study prints, and if you can, print them out in 12 by 18 on 12 by 18 paper. There's a cover page, a spline, and an index page, so you can print everything out and put it in a 3-ring binder. And the last thing is a test your knowledge question and answer for each unit, and that'll be in one file. You'll find all this material on the intro page. Click the PDFs, download the files, and you'll need to enter a password PR small f capital C RETE 2015 for all the files. And again, please note case sensitivity. If you have any questions, call me, Dan Dorfmiller. I go by the nickname of Dorf at dorfmiller.us. Look forward to hearing from you.
Now let's get started. Buildings today are designed and detailed using computer programs where the entire building is designed and detailed to full scale. The industry term is Building Information Model, nickname BIM, B-I-M. This allows the opportunity for the building to be viewed in many ways. The two most common being 3D models and renderings. And the other would be what we typically see on a job site, plans, elevations, sections and details. More on BIM later in the presentation. A pictorial drawing or a 3D view will help you visualize the structure in its entirety, or as seen here in this commercial building. Remember, you can't build it from this, but you will create an image of the finished product in your mind's eye view. Even elevations that show delineation of building materials can be a great value in accomplishing what the finished building will look like. As we can see here, we've got some, let me get this other pointer, some brick here, and you can see this is a standing seam roof, shows you how the windows are, some of the signage that might be on it. Things of this nature are very useful in beginning to understand the building. These types of drawings are enhanced by showing trees, landscaping, shading, and scale for people. Take for instance this Lego I recently built. The cover page provided me with an image to the final outcome of the model, so I had an idea of what I was going to end up with. The detailed step-by-step plans made it possible to build the structure. Orthographic projection is an old term used in producing drawings, which is a method of taking a building apart in its projected two-dimensional views, as seen here in this model. You can see here how we have a roof like that, and it's projected in its two-dimensional view like this, or for instance an elevation here which is projected on out into its two-dimensional view. Drawing organization starts with the title page. The title page will provide many facts about the project, such as the owner, the architect, civil engineer. Here we have MEP, which stands for mechanical, electrical, and plumbing, the structural engineer. And down here at the bottom we even have a site location map. Let me blow this up a little bit here so that we can get into the corner here. And you can see we have a symbol legend, a material legend showing a variety of materials, some general notes. And when you're first getting involved in plans, this set of abbreviations down through here can be very, very useful. Now let me move over here a little bit. And it doesn't show up great on this particular video, but you can also see that we have a list of plans. We have the civil plan. Let's see, what do we got here? The civil plans, the structural plans, the architectural plans, and a list of dates that they were last issued, which is also very useful when it comes to getting your contract later on in the project. This is where you'll always start when it comes to looking at plans, is the title sheet. Most sets of prints will start with the civil drawings, typically referred to by the prefix letter C, such as C1, C2, etc. Civil drawings will include such things as plot plans, site plans, landscape plans, site details. The site plan shows all the information outside the building. As you can see, the building has been identified here with a heavy, dark line showing the basic roof outline. While the site plan itself is showing you've got the street setback. I believe up here we've got a property line. It's got lots of dimensioning. We're showing the street in, all the parking stalls and all the dimensioning for the parking stalls. We're showing the patio over here, and some of the site details that you'll find on another page. Also note down here where it says architectural site plan, you see a little arrow pointing off to the left, let's see, the right hand side of the drawing. That would be the plan north arrow, which will be useful later on in seeing what elevations in north, south, east, and west type elevations. Here's another example of a major project showing the architectural site plan, and you can see here the buildings are outlined, quite a few different buildings at different elevations, and they're showing you the roofs. You can see where the roofs are from building to building. Now let me blow this up a little bit so we can kind of see a detail section of that. What I want to show you is we have some pochane over here and some legend for what the pochane means that is identified over on the project. Like for instance this darker gray area, some sidewalks that you have down along this area. That's very useful in identifying different types of materials on the job without having to write the material name down again and again and again and again. Found on this site plan is a blow-up from the previous site plan showing much more detail. This type of site plan is called a plot plan. This is how subdivisions are laid out, showing property boundaries, as you can see right here, which they have vectors on them. For instance, you see north 15 degrees 38 minutes and 47 seconds west. It's 640.93 feet long. That tells you how far it is from this point all the way down there over to this particular point. The plan will also show you all the different offsets, where the street is, where the setbacks are, where some easements might be down along a particular side of the particular property. And back on the vector thing, it's not something that we're going to really cover in this part of the program. You can just go to the website and type in bearings or vectors, and you can find some really good stuff on that. Architectural drawings are represented by the letter A, such as, again, this A1, A2. And you'll find in architectural drawings are going to be showing you the floor plans, elevations, finishes, building sections, schedules, and details. I like to think of the architectural drawings as all the gingerbread or all the stuff that goes onto the actual structure of the job that holds the building up. Most architectural drawings start with the floor plans. These plans are the plans that most people are familiar with. The floor plan is the locator for all the additional information. Floor plans are like horizontal sections taken about 42 inches above the finished floor looking down. So when you cut through doors and windows, you don't see the walls. On most commercial projects, you will find a column grid layout. As noticed on here, you have numbers 1, 2, 3, all the way up to, looks like number 10, and you've got the alphabet going up and down that way. This establishes, as you're coming down through here, this intersection establishes column line locations. Note on this drawing, we are looking at the lower level floor plan for the garage. You will find many dimensions, as you can see the basic layout of the column to column dimensions across the building. You will also find many section cuts, as you can see here, an elevation cut right there, a section cut, directing you to another page on the drawings. And again, also notice Plan North. Plan North down here is off to the right-hand side of the page. Here is an example of a simple elevation of an office warehouse building. Note the building's facade materials. We have brick and metal siding right here. The doors and the windows. That kind of gives you a feeling how the building's going to eventually look. Also note on this particular elevation, they've identified the column line system. Elevations also can be of interior surfaces that might need some clarification and detailing, as seen here in this particular conference room. Here we're looking at a conference room on the inside, looking to the outside window system of the building. There's your window mullions, there's your ceiling drywall stud system with the drywall and a light cavity like that right there. It gives you an elevation for the mezzanine floor, a roof elevation, or a gypsum ceiling elevation. Very useful in trying to lay out this particular coved ceiling. Sections are cut through portions of a building to show all the components and their relationships of how they go together, such as wall sections as seen here in this stair section. Note, there are still additional details indicated by these bubbles with flags that they're off to the side right here, to identifying which sheet to go look at. Also note that the floor elevation here at 100, they're showing a ceiling elevation, a top of steel elevation, a finished floor elevation, what do we have? A top of rail elevation, and a top of acoustical ceiling elevation. So what this does is just give you a relationship from the roof all the way down to the first floor with how all this particular stair goes into the building. This detail section view for a dock leveler on a warehouse building shows you, we have the foundation, we have the pit slab, a little piece of a knee wall, the slab kind of ties into it, shows the number 4 is at 16 inches on center, shows this little bar here, 24, 24, 24. So there's a lot of information on this particular detail. It also shows you the angle iron right here. Note, there may be some additional shop drawings from the manufacturer that you have to use to build this particular detail. Also note that as we've been looking through these drawings, we start off with plans, we have some elevations, we showed some building sections. The building sections took you to some additional details. So notice how we're going from the overall into the detail. Schedules are also another powerful tool in collecting a lot of information in one place. They are a list of materials or data, such as a door schedule or a room finish schedule, or if you're in the structural drawings, a column or a beam schedule showing sizes and number of rebar and things of this nature. You will find schedules used throughout all the different types of drawings by all the different disciplines on a project. Here is an example of a door schedule where each door is identified by a door number that relates to the room it will be located in. Taking a closer look here, let me blow that up so we can look at each room. you will see a door number. You got B101-A, which is a valet parking. Here on the second floor, you've got, for instance, a B202, says it's not used. How about a B204? It's in the living room. It tells you the width, the height, how thick the door is. That's got some aluminum and glass, clear painted. So again, the purpose of the schedule is to give you a whole lot of information about a particular product in one location, so you don't have to write all that information on every door throughout the entire project. Here's an example of a room finish schedule. For instance, room 100 is the vestibule, room 106 is a conference room. Note that the room finish schedule is going to show you the carpet material, the base material, that's the stuff we're running around the edge. If you're looking at the walls, it's going to refer to north, east, south, west walls. In most cases here, it's shown as all painted. For instance, what is the ceiling material? Tells you that it's going to be acoustical. Tells you what the ceiling height is. For instance, it's 9 feet. Looks like it's pretty consistent throughout the project. And down through here, you'll have some legends identifying some of the different materials that you might see up in the schedule. For instance, if you were a painting contractor, this would be a great place to go find out what walls are painted and how high the different walls are. On a structural drawing, a typical schedule might be a column, a footing, or a pier schedule. On this schedule, the engineer has outlined the column footers, the sizes here. It tells you which ones. Here's F5, it tells you 4 foot in diameter by 3 foot 6 min. It also gives you, see, an F3 is 11 foot 6 by 6 foot by 1 foot 6 deep. Gives you the rebar, and it tells you what the top of the particular footing is. Again, for a concrete contractor, this would be a great place to go collect all the information about all the different kinds of footings. Every place you saw an F1, you would know it's a 7 by 7, 1 foot 6. And if you had 10 of those, you could just add all that material up real quickly. Next in the set would typically be the structural drawings. The structural drawings are usually identified with the letter S, such as S1 and S2. The structural drawings are that portion of the drawings that identify the structural components of the building, such as concrete, masonry, steel, wood. It's what makes the building stand up. The foundation plan is typically the first drawing in the structural set. Like the lower level floor plan, the foundation is the lowest level of the structure. It is what the rest of the building sets upon. This foundation plan is for an office warehouse. Notice the grid system identifying the layout of the column locations. When columns fall between two even column lines, like for instance E and D here, they call this D1, D6, D8, kind of like as a percentage of the distance it is from one to the next. This is also where most of your sections are going to be cut. Notice here we have sections and details directing you to different portions of the drawings that you can go look at. Also note you may find some information related to the exterior. As we look up here, there's the outdoor patio. Again, it's outside the building. It should be, sometimes it might be on the civil drawings. In this particular case, it's shown on the structural drawings. Also looking here a little closer at the title block. Well, let's take a look at what the scale of the drawing is. The scale is 1/16 of an inch equals 1 foot 0 inches. What that means, for every 1/16 of an inch in plan, that equals 1 foot 0 inches in real life. And we'll talk a little bit more about scales. In fact, we have a whole unit on scales a little later on in this training program. Frequently on a foundation plan you will find notes and information related to the slab and subbase, as noted here with this 6-inch slab showing fiber mesh with a 4-inch compacted granular fill subbase. Also noted here are the construction joints, typical east and west column lines, a joint on the column line and a joint here on the center of the column line. Structural framing plans are the plans showing how the structure is built above the foundation and are related to each floor and roof plan. Here is a structural framing plan for the mezzanine level of that office warehouse we were just looking at. Notice all the column lines that we have here are the same column lines that are referenced on the foundation plan earlier. The mezzanine floor slab construction is also found as a note off to the side of the plan here. Additional prints in the construction documents such as mechanical, electrical, site utility plans, plumbing, heating, ventilating, and air conditioning, commonly referred to as HVAC, all have their particular identifying marks such as M1, M2, and the E1, E2, and H1, H2. That's how those plans are identified as you go on through the set. Remember where you find all this information, again, is back on that title page. Here is that same basic floor plan showing the office warehouse that we were just looking at, now just simply showing the plumbing plan as it relates to the entire job. The industry refers to prints in many ways. Prints, blueprints, the plans, the working drawings. I personally feel like the official word would be the construction documents. The word blueprints came from the old way of drawing on vellum with pencil and or ink and making copies by running the tracings with an additional piece of paper that was light sensitive and then exposing the paper to ammonia, causing the paper to turn blue, leaving the light lines or white lines. All documents today are printed directly from the computer through a BIM type file or are converted over to a PDF and then printed. When handling drawings, there are a few basic considerations that need to be observed. Never write on the prints unless making authorized changes. I know that sounds a little bit silly, but it makes a big difference later on. Remember, somebody else may come look at this print that you weren't, that may have no idea why you make those marks on the drawings. It should be obvious. Keep them clean. Don't use or don't eat or drink over the prints. I do not like to see the prints folded. Roll the prints carefully. Do not lie, obviously. Sharp pointed objects on them, and keep the prints out of direct sunlight because the light, they are sometimes light sensitive, and store them in a dry place. Here's a really good example of what not to do. Moving on to understanding the graphic language of drawings. What the alphabet is to words is what lines and symbols are to drawings. The weight and configuration of a line determines to some degree what that line might mean on the construction document. The border line will be the heaviest line on the document, with the object line being the next heaviest line. The property line also can be in here, and notice that it was a long line, two short lines, or two dots, a long line, two short lines. For instance, we have a hidden line right here, and that is just a bunch of short dash lines, a little bit lighter than the object line. And then you have the center line down here, which is usually one of the lightest lines on the drawing, usually a real long line, a short dash, long line, and a short dash. The weight of the line kind of begins to determine how you look at that particular piece of the drawing. The dimension lines we have here and the leader lines are used to dimension the project. And notice that every architect's going to have their own little way of identifying the way this dimension line is stopped. If it's from here to here. Notice they use little dots there, here, which is most typical, and it's what I use when I draw. I use these little slash marks like that. Each architect will have his own unique way of doing this. Break lines are commonly used to indicate that something will continue on past, like this piece of wall is shown here by this little break line, meaning it's going to continue on up in that direction, or a little shortcut like this, that this line is going to continue over here and continue over here. If you're looking at this caisson down below, you see these caissons underneath this footing. They're going to continue on down, and they show that with this little squiggly line like that, kind of showing like it's circular, and these caissons are going on down into the ground. One of the most important items of nomenclature would be the section cutting line indicator. Again, each architect or engineer will have their own unique way of identifying this, but will always be in the same basic concept. And that concept is, first of all, it's going to cut through something and it's going to show you the direction that the section is facing or which way it's looking. The next piece of that is there's going to be some kind of a circle, or down here you see some kind of a square. Almost always the top part of the circle or block is going to be the section identification, and the lower portion of this will be the sheet number that the section or detail is located on. Symbols are widely used on drawings to present common or typical items on the documents, such as the door number or a window tag. Something that's pretty common throughout the entire industry will be this triangle for a revision tag, or this elevation mark with a circle and either side of it opposing sides darkened in, identifying an elevation mark on a drawing. To identify common type materials such as, let's get the marker back here, such as earth or granular material. Brick is real common, shown by these angular lines. Obviously, concrete is a real common material, shown by all these little little dots and pencil mark lines. Bad insulation, shown as these squiggly lines going up and down. Our continuous lumber, shown as this little X line like this. Very typical throughout the industry, very typical on drawings, and it's not uncommon for people to have a materials legend identifying the types of materials that'll be on your drawings. What I'm trying to indicate here is just here's some more drawing symbols by different architects. Let's see, I was looking for that here, the revision sign right here. The revision mark is still a triangle. Elevation mark is your circle with the opposing sides, quarter sides, darkened in. Earth is a little bit different than the one you saw earlier here. The things are going on slight angle. Gravel is showing little circles. Concrete still shown as those little pencil-like marked dots. Your typical framing lumber is still showing as kind of like an X right here. So the symbols are very similar from architect and engineer to architect and engineer, but they'll have their own little could also have their own little variation. Seeing the lines and symbols all together can be sometimes confusing. I always orient myself by looking at what page am I on and what am I looking for. And also I look at where the center lines of the columns are. So it kind of gives me an orientation of what portion of the building that I might be looking at. So note that the column center lines, again, are these long, short type of lines. They come down here to a bubble. You have one, and someplace over there two, and you've got a couple of indicators where a column or some kind of a dimensions over here. So you've got a 1.3 and a 1.4 and a 1.7. I believe one of the most interesting things about this particular plan here is you see these dashed lines right here, and most people, when you ask them, will tell you, oh, that's the footing below the slabs or below the earth, so it's shown as a hidden line. Okay, I asked the question is, well, if that's a hidden line, then what are these little dashed lines? And some people are a little bit confused by that. And of course the answer is, because of this little flag detail, that's a detail of this particular footing shown on detail 1 on S-2, which is a typical footing detail. Here is a partial floor plan for a car dealership. Nope, column center lines coming down through here. We got our dimensioning line coming across there. Note you got a little tick mark showing you from dimension to dimension, or column line to column line. We've got a wall kind of showing right here. Notice it's just a little bit darker than some of the other walls. We've got some a dashed line here, and we'd have to go look at a note and find out what that meant. It could be a footing, it could be a recess below. We've got a dashed line here, which probably means something than that one. This one we know is a detail on 6.07 for a stair detail. Also note on this particular drawing we've got room names and room numbers. There's a consultant 10110, an office 116 over here. Even a little corridor is marked, corridor 114. That way when someone's looking at what the finishes are coming across this area here, they would know to go look on the plan to take off that area, maybe as VCT tile or quarry tile or something of this nature. Remember, the floor plans is what we use as the project locator for the rest of the information on the construction documents. All trades will use symbols and legends to facilitate graphic information on the drawings. Like these lighting symbols that the electrician might use, or the plumbing legend that a plumber might use. Other types of symbols on drawings showing specific kinds of materials is called pochane. Again, each architect or engineer might vary somewhat from this information that you see here. This is also in your student handbook. The pochane may vary whether you're looking in elevation or section. Becoming familiar with these and what the variances might be from drawing type to drawing type will be very important to help that mind's eye view when you're viewing the drawings. Landscape and topo drawings will also have their own little pochane. Notice here we have a dash line that happens to mean a water line. Over here we have another dash line that means a septic field. So you kind of have to know what you're looking at on a particular drawing. Well, here we got another one. Here's a dash line is an estimated contour line. So dash lines are probably, along with solid lines, are the second most used drawing or symbols on drawings, and they can indicate a variety of different things, so you have to become familiar with that. Here are some plan symbols. For instance, a door shows you the way the door is, and the swing is kind of important. Windows are typically shown as, of course, you got kind of a solid line on both sides, and they show this little extra line here in the middle. A stove showing those four little stove tops and a sink like that. Very common toilet kind of a look, or a bathtub type of a look, or a shower type of a look. Again, these are all symbols used on different portions of the drawing. Here's some additional plumbing symbols. HVAC symbols. And electrical symbols. Now, electrical symbols have lots of different pieces of nomenclature to it, and when you've been reading drawings for years and years, you'll start to just look at it and they'll mean nothing. They'll mean something to you just instantly. In the beginning, it's all a little bit like hieroglyphics. How to find information on the drawing? Well, number one is find the title sheet and review the title sheet. Find out what you're looking for in your portion of the work in the drawing, or what particular thing that you happen to be needing to look at today. The first thing I do when I first get a set of drawings is I flip through the entire set of drawings. And yes, I still do that today. The next thing I do is I tag out key pages that have information on it, like schedules and beam schedules, or a particular first floor plan that I'll know the second, third, and fourth floor plan levels might be right behind it. And of course, the last thing that I do is I begin to highlight or color up the drawings based on the type of work that it might be. If I'm an estimator, I'm going to color it in, kind of color it in as I take the information off. If I'm building a job, I might highlight the different portions of the work that are being completed. So you can kind of develop your own system as to how you want to use that part of the drawings. Here's simply an example of a simple tabbed out set of drawings that I was working on. Remember, learning to read prints is both visualization and interpretation of the information on the drawings. Remember, if you get it wrong, it could look like this. Okay, go to your student handbook and do the 6 pages of exercises at the end of Unit 1. Answer the multiple choice questions on pages 1, page 2, and page 3. On page 4, interpret the following symbols and materials. On page 5 and on page 6, using the Gateway Project drawings provided, answer the 13 questions. When complete, continue the video and the answers will be provided. Stop the video now. Now let's review. Number 1. What is not a common drawing? C. A painting drawing. Number 2. What type of plan would show the ceiling fan location and switch? B. An electrical drawing. Sometimes you might find them on an architectural simple floor plan. Number 3. Which type of drawing would show the property lines? D. All the above could possibly show it. A grading plan, site plan, and if it was specific, it would be a plot plan. Number 4. A list of items such as doors, windows, column sizes, and room names included on a drawing are called D. A schedule. The best use for a rendering would be to show detail of an exterior elevation. True or false? The answer is false. The term BIM means B. Building Information Model. Number 7. Column center lines will change from plan to plan in the same set of drawings. True or false? That is always false. Number 8. A short dashed line on a drawing indicates a detail shown on another drawing, a hidden line, a cold water line, all the above. And I believe the correct answer to be all the above, depending on what type of drawing you're looking at. Number 9. Fill in what the top or bottom portion of the circle of the following symbol relates to. Well, the top part of the circle will almost always be the detail number, and the bottom part will always be the page number. So that's A and B. Number 10. When opening and viewing a new set of construction documents, the first thing you need to do is this. Highlight your work, sign and date the drawings, flip through the entire set on the page, make a copy, or all the above. And I believe the answer to be C. Flip through the entire set page by page. Number 11. When should you not write on the drawings? And the answer to that would be C. Phone numbers of suppliers on the job. We don't need to be writing the phone numbers of the suppliers on the construction documents. Number 12. Using the corresponding letter CAS, EP, or M, standing for civil, architectural, structural, electrical, plumbing, or mechanical drawings, you would get these following answers as you come down through here. Notice the only one that I've put 2 in there for is dock leveler details. You may find some information on the structural drawings that will be useful and on the architectural drawings. And that could be even true for some of the others also, but typically they would relate to the types of drawings that I have indicated here. I will hold this page open for another 10 seconds, and you can get your answers. Number 1, the circle with the 3 lines is a 230 volt outlet. This circle right here with the lines coming up at the top, the bottom, and the 2 sides is a ceiling light fixture. Number 3, the S with a small d is a dimmer switch. The circle with 2 lines off to the side here is a duplex receptacle. The number 5, the circle with the 4 little pieces coming off of here at the F in the middle is a ceiling fan outlet. Number 6 would be a duplex receptacle. The S means switch. Number 7 is a fluorescent fixture. Number 8 is a recessed light. Number 9, a circle with a T, is a thermostat. Number 10, S, is a single pole switch. Plumbing symbols. Number 11 is a hot water line. Number 12 is a clean out, and you can tell by this little thing coming off to the side. Number 13 is a gate valve. Number 14 is a floor drain in plan. Number 15 is a hose bib in plan. Topographic symbols. Number 16, this lines here with the X is a fence. Number 17 is large stone. Number 18, power line. Number 19, sand. Number 20, sewer line. And just think, remember, on a plot plan, this might look like railroad tracks. Number 21, water. Number 22, bad insulation. Number 23, glass in elevation. Number 24, common brick in section. 25, rubble in elevation. Number 26, dimensional lumber in section. And number 27, cast concrete or cast in place concrete in section. Now, using the gateway tower drawings, number 1, who is the main architect? And that was CityWorks. 1A, where do you find this information? TS1, the title page. Number 2, what sheets are the following information found on? 2A, pile cap schedule, that's S3.1. The 8th and 9th architectural floor plans, that's A1.4. The demolition plan is C4, and the stud rail schedule would be S5.3. Number 3, how are existing trees indicated? And that's the symbol for it. What does the symbol indicate, which is this long line with the X's through it? It represents an existing fence. Which way is site north pointing? Now remember, I'm saying site north on this page, and that would be toward the top of the page. When you're on the plans, it's going toward the right-hand side. Where is the emergency generator located? Lower level of the outdoor mechanical area. Number 7, what window symbols and numbers indicated on the following floors? On the first floor, it's W1. On the third, you'll find W14, 6, 12, and 10. And on the 8th floor, W15, 6, 13A, and W11B. How is the spandrel glass indicated in elevation? And it's done with these little slanted, close together lines. Number 9, what must all concrete work conform to? And that is the ACI Building Code, ACI 318-301, notice always latest edition. What pile cap is designated for corners of the building? That would be PC2 and PC4. What is the plan elevation of the lower level? Minus 10 foot 0 inches. What sheet is the 6th floor framing plan on? And that is S2.7. And what is the diameter of the auger cast piles? 16 inches. You have completed Unit 1, Introduction to Drawings and Symbols, the alphabet of drawings. If you have any questions, please contact me, Dan Dorfmiller, at my email address, dorf@dorfmiller.us. And from here, please continue to Unit 2, Construction Math. Here you will learn some basic math and how it applies to the construction industry.